Deep within the ruins of Chernobyl, scientists made a surprising discovery. A black fungus known as Cladosporium sphaerospermum growing directly on the walls of Reactor 4. This organism stands out for its extraordinary ability to survive and even flourish in one of the most radioactive environments on the planet. Unlike most life forms, Cladosporium sphaerospermum not only tolerates high levels of radiation, but appears to use it as a source of energy. Its resilience has sparked interest among researchers, who are now exploring how this fungus manages to thrive where few others can. The unique adaptation of this black fungus offers intriguing possibilities for science and technology, especially in environments where radiation poses significant challenges. Radiosynthesis is a remarkable biological process that allows certain fungi to thrive in environments saturated with radiation. Cladosporium sphaerospermum, discovered in the ruins of Chernobyl, exemplifies this adaptation by absorbing gamma radiation and converting it into chemical energy. Unlike plants, which rely on sunlight for photosynthesis, this fungus uses high-energy radiation as its power source. Its melanin-rich cells are believed to play a critical role in capturing and transforming radiation, enabling the organism to not only survive but flourish where most life forms cannot. This unique capability demonstrates nature's ingenuity in evolving survival strategies for extreme conditions. The study of radiosynthesis offers insights into how life can persist in environments previously thought to be inhospitable and may inform future applications in both environmental science and space exploration. In 2024, Cladosporium sphaerospermum was sent to the International Space Station to test its resilience and behavior in space. Remarkably, the fungus not only survived the harsh conditions but also thrived, forming a thin biofilm on surfaces. This biofilm demonstrated the ability to block up to 84% of incoming cosmic radiation, a significant achievement given the dangers posed by space radiation to astronauts. The experiment suggests that this fungus could serve as a natural, self-regenerating radiation shield, offering a lightweight and adaptive alternative to traditional protective materials. Such biological shielding could be especially valuable for long-duration missions, where conventional barriers are often impractical due to their weight and bulk. The success of this experiment opens new possibilities for using living organisms to enhance safety in space exploration. Cladosporium sphaerospermum has attracted scientific interest for its potential role in bioremediation, particularly in environments contaminated by radiation. This black fungus is uniquely adapted to metabolize radiation, making it a promising candidate for cleaning up nuclear disaster sites that are hazardous to humans. By absorbing and converting gamma radiation into chemical energy, the fungus could help reduce radioactive contamination in affected areas. Its resilience also suggests broader applications for survival in extreme environments, such as deep space or other planets, where radiation poses a significant threat. Researchers are exploring how this organism might be harnessed to create self-sustaining biological shields or remediation systems. The ability of C. sphaerospermum to thrive where most life cannot opens new possibilities for environmental recovery and human exploration beyond Earth.